Okay, so picture this. You've got Albert Einstein,
Right.
one of the biggest brains to ever, walk the earth. And he's wrestling with this huge question, this massive problem, like how to describe the entire universe.
And he comes up with this incredible framework, this really elegant theory. We call it the general theory of relativity.
Yeah, exactly. And it totally revolutionized our understanding of gravity, right? How we think about, mass and energy and space-time.
But then he hits this snag, like his equations are kind of pointing towards something that doesn't quite fit with what everyone believes at the time.
A static universe.
Yeah, everyone pretty much agreed back then that the universe was this fixed thing,
Hmm.
right? Like it just existed, it didn't change, it didn't move.
Right. It was just kind of like this cosmic stage where all the action happened.
Exactly. But Einstein's equations were hinting that it wasn't static at all. It had to be either expanding or contracting.
Which kind of threw a wrench in things, right?
It definitely created a bit of a dilemma for him.
Mm.
So what did he do? He basically introduced a little fudge factor.
This is where the cosmological constant comes in.
Exactly. Represented by the Greek letter lambda, it was this like tiny little addition to his equations, a tweak, if you will.
Yeah, like a cosmic counterbalance.
And it acted as this kind of outward push, this energy inherent in space itself that would counteract the inward pull of gravity
Right.
from all the matter in the universe.
To keep everything nice and balanced and static, just like everyone thought it was.
It was like the perfect fix at the time.
Yeah, it seemed to solve the problem, but little did Einstein know this was just the beginning of the story.
This is just the tip of the iceberg. So welcome to the deep dive, where today we're going deep into the crazy story of Einstein's cosmological constant. This concept, this idea that went from being, his biggest blunder to potentially the key to understanding how our universe is expanding.
It's wild, right?
Totally wild. And it really shows you how science works.
Hmm.
It's always evolving. It's a constant process of questioning and revising, and sometimes even admitting you were wrong.
Well, supposedly wrong. So to understand all of this, we got to go back in time a bit. It's 1917. The world is in the middle of World War I, and Einstein is busy, finalizing his general theory of relativity.
And this theory, it's mind-blowing. It explains gravity not as this mysterious force, but as a curvature in the fabric of space-time caused by mass and energy.
Right. But like we said, his equations were hinting at a non-static universe, which just didn't jive with the common scientific belief at the time.
So to bridge that gap, to reconcile his brilliant theory with what everyone thought they knew about the universe, he introduced this cosmological constant.
This outward push to counteract gravity's pull and keep the universe still.
Exactly. It was like adding an ingredient to a recipe to make it taste just right.
So for a while, everything seemed to fit right. Einstein's theory explained gravity, the universe was static, just like everyone thought, problem solved.
Right. But then fast forward about 12 years to 1929, Edwin Hubble enters the picture.
Yeah, the Hubble Space Telescope guy.
Yeah, that's the one. And he makes this groundbreaking observation that changes everything. He's studying these distant galaxies, and he notices something really weird. The farther away a galaxy is, the faster it seems to be moving away from us.
So it's like imagine baking a loaf of raisin bread. As the dough rises, all the raisins spread further apart.
That's a great analogy. So Hubble's observations show that the universe wasn't static after all. It was expanding.
Which completely contradicted the whole idea of a static universe that the cosmological constant was designed to support.
It was a major blow to the prevailing scientific wisdom.
And when Einstein heard about Hubble's discovery, he was like, oh man, what have I done?
Right, he reportedly called the cosmological constant his biggest blunder. This unnecessary addition to his otherwise beautiful theory.
So for the next 70 years or so, the cosmological constant was basically put on the back burner, right? It became this kind of forgotten footnote in the history of science.
Physicists were all about the expanding universe. And the big question became okay, is this expansion going to keep going forever, or will gravity eventually pull everything back together?
Right, will the universe collapse on itself?
Yeah, that was the debate. But no one was really talking about this repulsive force, the cosmological constant, anymore.
But then, boom, 1998 rolls around, and two teams of scientists are studying these distant exploding stars, supernovae, and they stumble upon something that rocks the scientific world.
These two teams, the Supernova Cosmology Project and the High-Z Supernova Search Team, they were looking at these special type of supernova that are like these reliable cosmic beacons.
Yeah, because they explode with this consistent brightness, so scientists can use them to measure distances in space.
Exactly like standard candles.
Mm.
And by studying these supernovae, they could track how the universe's expansion had changed over billions of years.
Like looking back in time.
Yeah, pretty much.
Yeah.
And what they found blew everyone's minds. They found that the expansion of the universe wasn't slowing down, it was actually speeding up,
Accelerating.
accelerating,
Yeah.
which was the complete opposite of what everyone had expected.
So all of a sudden, this idea of a repulsive force pushing everything apart didn't seem so crazy anymore.
It was like Einstein's cosmological constant was suddenly back in the game.
It was the only thing that could really explain this accelerating expansion.
This mysterious energy that was counteracting gravity on a cosmic scale.
And talk about a comeback right from biggest blunder to potential key to understanding the universe.
It's a pretty remarkable turn of events, and it really speaks to how science is always willing to re-examine its assumptions in light of new evidence.
And what we once called the cosmological constant is now what we often refer to as dark energy.
Yeah, dark energy is this like blanket term we use to describe this unknown force that's driving this accelerated expansion. And the cosmological constant is one of the main ways we try to understand it.
And it's crazy to think that like 70% of the universe might be made up of this stuff that we know next to nothing about.
Yeah, it's mind-boggling.
Yeah.
It really makes you wonder what other scientific ideas that were initially dismissed or ridiculed might actually turn out to be true.
Like Alfred Wegener's theory of continental drift. For a long time, people thought he was nuts.
Right back in the early 1900s, he proposed that the continents were once all joined together in this supercontinent called Pangaea, and that they had slowly drifted apart over millions of years.
And he had some pretty compelling evidence, too, like the way the continents fit together like puzzle pieces and the fact that you find the same fossils on continents that are now separated by oceans.
But people just couldn't wrap their heads around how these huge land masses could possibly move.
There was no known mechanism to explain it.
Right, so his idea was largely rejected for decades.
Until the 1960s, when the theory of plate tectonics came along and explained how the Earth's crust is broken up into these plates that are constantly moving and shifting.
And suddenly, Wegener's theory made perfect sense.
It's amazing how an idea that was once so controversial is now like a fundamental principle of geology.
It just shows you that sometimes it takes a while for science to catch up with the truth.
And even Einstein himself was wrong about some things.
Well, he wasn't exactly wrong, but he was definitely skeptical about some of the implications of his own theories, like black holes.
Yeah, he predicted their existence based on his theory of general relativity, but he wasn't totally convinced that they could actually exist in the real world.
He thought they were just like these mathematical oddities.
But as time went on and we got better at observing the universe, the evidence for black holes became overwhelming.
And then in 2019, we actually got the first ever image of a black hole. It was like this huge moment for science.
It's incredible to think that something that was once just a theory is now something we can actually see.
It's a testament to the power of human ingenuity and our insatiable curiosity about the universe.
And speaking of scientific pioneers who didn't always get the recognition they deserved, there's a story of Edwin Hubble and the Nobel Prize.
Yeah, it's kind of sad, actually. Hubble's discovery of the expanding universe was this monumental breakthrough, but he never won a Nobel Prize for it.
Because back then, the Nobel Committee didn't consider astronomy to be real physics.
Can you believe that? And by the time they changed their minds, Hubble had already passed away, and the Nobel Prize can't be awarded posthumously.
It's a shame that he never got the official recognition he deserved, but his legacy lives on in his discoveries and the Hubble Space Telescope that's named after him.
It's a fitting tribute to a truly remarkable scientist. So where does all of this leave us? What can we learn from this whole saga of Einstein's cosmological constant?
Well, I think the biggest takeaway is that science is a process. It's not about being right or wrong all the time. It's about being willing to question your assumptions, to be open to new ideas, and to admit when you've made a mistake.
And sometimes what we initially perceive as a mistake or a blunder can actually lead to a deeper understanding of the universe.
Like in the case of Einstein's cosmological constant. His supposed blunder turned out to be a crucial clue to the nature of dark energy and the accelerating expansion of the universe.
It's a reminder that we should never be too quick to dismiss ideas that seem unconventional or out there. Because you never know what amazing discoveries might be lurking just around the corner.
And for you listening out there, the next time you encounter an idea that challenges the status quo or seems a little bit crazy, don't be afraid to think outside the box.
Remember, Einstein himself doubted his own brilliance. And look where that led us.
It led us to a whole new understanding of the universe. And who knows what other incredible mysteries are still out there waiting to be uncovered.
So keep questioning, keep exploring, and never stop wondering about the vast and mysterious cosmos we call home.